The thing I'm gonna now explain you is the Young's double slit experiment. This was done to prove that is light a wave or particles, like the Newtonian physics particles. So the experiment was like a single point source of light. In front of this, two cardboards with a small pinhole, two pinholes with a distance between them of wavelength of light, say 400 nanometers, 500 nanometers, or 5000. 500 to 5000 nanometers would be okay for this experiment. So when the light was turned on, what could be the observations? What do you think? Most of you, what we will tell, a screen was there in front. So this was the screen, something. What you will see, what most of you think, there would be two lines as usual. But here comes the twist. There were not two lines. There were many lines. The brightest light was in the middle. There was a dark space after that. Again, a slight lighter light was there, and it continued till 90 degree, 180 degree from that cardboard sheet. 180 degree, like this to like this, 180 degree. From within the 30 degree, 30 means 60 degree. This would be the 60 degree. It was quite visible, but after that it was not much visible. So how did this thing happen? This is the characteristic of wave, the electromagnetic wave of light. So I would like to give you one example of that. So come with me. Okay, so these are the two light rays from this point source. Okay, so I would not draw because this is a much pricey chart. So suppose these were the two endings, okay, and light came. So what happened? For understanding this, you would need to understand one concept first. Every wave has a characteristic of if. So suppose I am drawing something. Yes, this is a wave. Okay, my drawing is not much good. And this is another wave. See, the trucks align with trucks. The peaks align with peaks. So what will happen? A more bigger wave would be formed. But if the trucks align with the peaks, so like this something, if the trucks align with the peaks, this would cause a straight line if these both are equal. So this scene is called as destructive interference. Destructive interference. And this is called as constructive interference. So what happens? This was so I am drawing the screen. Okay, this, and this. This one is the brightest one. Okay, and here is the dark spots. How did this happen? So these were the two. Very small distance was there, so that they were gradually parallel, meeting parallel to each other. They were meeting parallel to each other. So now what happened? At this point, both the waves align each other. So suppose I would tell you with this example. So these are peaks, these are trucks, these are peaks, these are trucks, these are peaks. So same with this hand. Now the peaks align with the peaks. So what was the here? The peaks align with the peaks. We shifted the point over here, and now the trucks align with the peaks. Now this would happen, the destructive interference. Now after some time, they both again came with each other. The peaks align with the peaks. So constructive interference, this line. Again same, again same, again same, again same, and this was the pattern formed. So after the most of the debate, the problem of light, whether it is a wave or photon, were solved. But after some time, this wave characteristic was not able to, in 19th century, was not able to tell the reason why light bounces off from a mirror. I would tell this in the next. I would tell the Newtonian theory of light in the next video. Till then, goodbye.